Frontier AI models possess incredible reasoning capabilities, but they stop at the enterprise perimeter. This is the last mile problem. These models can't see your private data, which means they struggle with niche industry jargon and the specific history of your company. It creates a security paradox. Exporting sensitive data to a public API violates zero-trust policies, but keeping the model isolated leaves it without the context required for high-level business logic. Treecapital AI engineered the Anven 1.0 architecture to resolve this friction point. It is a sovereign AI, built to deploy and operate entirely within air-gapped private enterprise clouds. Once secured on premises, architects adapt it to the business using two distinct optimization paths. Specializing the internal architecture replaces the risk of relying on generic rancid intelligence. To choose between these paths, architects evaluate specific business friction points using a decision matrix. The matrix shows the logic. If the primary goal is factual accuracy with rapidly changing information, the path routes to the left. This leads to Retrieval-Augmented Generation, or RAG. It functions like an external librarian, fetching information from a database to support the model's response. In this workflow, a query is converted into a numerical vector, matched against internal documents, and then fed directly into the prompt as specific context. This process grounds the AI's responses in verifiable internal citations, significantly reducing the likelihood of a fabricated answer. RAG provides a reliable external memory, but it does not change how the model reasons or the specific way it formats its output. Scenarios involving deep industry logic or strict structural requirements, like YAML, require a different approach. In the decision matrix, these goals route down the right-hand branch toward fine-tuning. This process focuses on model execution rather than data recall. Developers use parameter-efficient fine-tuning, or PEFT, to modify behavioral patterns without the massive compute costs of retraining the entire model. This diagram shows a PEFT methodology called LoRa. It injects specialized matrices into the model, baking proprietary jargon into the weights. Because this logic is part of the weights, it reduces prompt token overhead. In production, this can cut compute costs by up to 60%. Fine-tuning sets a new cognitive baseline, specializing the model for a specific trade. High-performance enterprise systems often orchestrate both of these strategies simultaneously. The Anven architecture unites these branches natively. It allows a single workflow to use customized weights alongside real-time vector search. In a legal tech setting, the model uses its fine-tuned weights to parse complex syntax, while simultaneously pulling current facts from active case files via RAG. Anven's late fusion architecture extends this further, processing visual evidence and text in the same reasoning space. Combining structural fine-tuning with factual grounding creates a reliable engine for complex business workflows. This framework allows global industries to activate proprietary data they've collected for years. It transforms disorganized, unstructured files into a private, high-density digital asset. Frameworks like Anven allow enterprises to deploy private models that match frontier performance entirely within their own firewalls. Internal telemetry stays protected, as the intelligence layer runs without any external network dependencies. Transitioning intelligence from a rented service to a fully owned asset allows a business to control its own cognitive future.